5 variable K-map. See here. Here we have 5 variables. For example, A, B, C, D, E. Here also we take 4 variable K-map only for the last 4 variables, that is B, C, D, E for example. And here first time we take A equal to 0 and second we take A equal to 1. Two possibilities we have. Okay, see here. Now, how to write the minterms? First K-map is same as 4 variable K-map, that is, it is minterm 0, 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 14 and 15. This is what we discussed earlier also. Now here in the second K-map, first A is 1. If A is 1, 1 followed by 4, 0, what is the equivalent is 16. 1, 0, 0, 0, 1, 17, like this. 20, 21, 22, 23, 4, 5, 28, 29, 30, 31, because all ones, 5 ones is 31. So this is each box represent one minterm. These are the minterm contents in your 5 variable K-map. Okay, so keep the heading 5 variable K-map. So how we make 5 variable is with the help of 2 4 variable K-map. One time we take the MSB A equal to 0. Second time we take the MSB A equal to 1. Okay, copy it. First copy the structure. Okay, now listen here. Let us take one question. Right. So let us take one question. Suppose this is the K map given, they ask you to minimize. See here. Here, firstly, you can make one quad. And here also you can make a quad. And this one is there, you can take one pair here, one pair here. Total how many pairs will come? 2 pairs. Instead of that, we can do like this also. If any particular term or pair or any group is common in both the K maps, if they are common in both the K maps, then we can make the grouping between the two K maps. Because here, suppose this is one single term, this is one single term. Both of them you can make it as one pair. These two will become one pair. In that case, what is the, because if you write this single term, what is the expression? B bar C D E. What is the expression for this? B bar C D E. Okay. So for this it is B bar C D E into A bar. B bar C D E into A. If you take B bar C D E common, here A bar plus A. What is the answer? A bar plus A is 1. Okay, so if any particular term is common in both the K maps, then you can make a grouping of both and neglect A. For example, see, first for this quad, how to write the expression is, quad expression is what? Here it is C, here it is E bar. But for total K map, what is common is A0, that is A bar should be written compulsory for this, plus for this quad, what is the condition here? It is C bar and E. And for this total K map, what is common? A is common. Plus, now see here. So for this total K map, A bar, and for this total K map, A is common. So if you take a single term here, that term into A bar, that particular term into A, if you take the term common, A bar plus A will be neglected. So you can make a grouping between these two cells, which will make a pair, which will give you B bar C D E into A bar plus A will be neglected. Now you may have the doubt, sir, why don't I take this pair? If you take this pair, then you need to take this pair also. How many pairs you need to make? 2 pairs, which is not required. So instead of that 2 pairs, we can take a single pair by grouping the cells between the 2 K maps. So grouping is possible between the 2 K maps of if you have at the same position in both the K maps. If you have at same position, whether it is a pair or single term or quad or octet, if both of them are at same position in the K map, you can make a grouping and neglect what? A in the expression. If you don't neglect A, for example, if you take a pair, take pair for example, if you have doubt, it is B bar C into D into A bar. How many? 4 literals. For this again, B bar D into A, another 4. 4 plus 4, how many? 8 literals are coming because 2 pairs. Instead of that, if you group these two, it will make a pair and it is giving me 1 pair and how many literals? 1, 2, 3, 4. 4 literals. So which one is advantageous? Definitely taking the grouping of this one in both the K maps with a single pair is advantageous. Always if you have doubt, we should check which one is correct. If you have doubt, write both the possibilities. Whichever is giving you least literal count, that is your answer always. Least number of literals is the least literal count is the answer always for you. Okay. So see here, So after taking that pair, this will become, it is not required, which will become what? Redundant. Similarly, after taking this one, this will become redundant. So any cell is common between two, you can make a grouping of that. So you may have the doubt, sir, suppose I have here one cell, here one cell, can I make a group? No. It should be in the same position. Okay. Why? Because it should satisfy adjacency property. If it is in same position, 4 bits will be same, only A will be differing. 5th bit, only 1 bit is difference. Then only you can make the grouping. Okay. So this is how you make the 5 variable K-map. We should take two 4 variable K-maps and solve it. Copy it. Right. Let us open your classroom workbook. And see question number 29. 6 variable K-map. Read the question. See, first here previously 5 variable K-maps, we take A0, A1, we draw 4 to 4 variable K-maps. Here we take 4 variable K-maps C, D, E, F, and here A, B can be 0, 0, 0, 1, 1, 1, 1, 0. So A, B has 4 possibilities. So here we take 4 variable K-maps. Okay. Please make 4 variable K-maps. First time you take A, B, 0, 0. Okay. So CD can be 0, 0, 0, 1, 1, 1. Like this, we should make 4 K-maps. Next one, A, 0, 1. And again, CD, E, F. Okay. Next, AB. One second. This is AB 0, 1. Next AB 1, 1, 0, 0, 0, 1, 1, 1, 1, 0. Okay. Same order. CD, E, F can be lastly CD, E, F can be 0, 0, 0, 1, 1, 1, 1, 0. Right. This is for AB 1, 0. So this is your structure of 6 variable K-map. So here, what is the mean term here? Here same as previous case, 0, 1, 3, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Next, 16, 17, 19, 18, 20. It is how to read A, B, C, D, E, F. We read it. Okay. 23, 22, 4, 5, up to 31. Next here 32 will come because 1, 0, 0, 0, 0, 0. So 32, 33, 36, 7, 9, 8, 40, 48, 50, 60, 61, 62. That's all. This is your structure of 4 variable K-map. All ones is your 63. Okay. Now we will do it. First copy up to this. Right. Now let us implement this. So please listen here. 6, 9, 13, 18, 19, 25, 27, 29, 40, 1, 45, 57, 61. This is given by examiner. These are the K-map according. Now you can form one pair. This is a single term. You can form one pair, and this is another pair, 18 and 19, and you can form another pair. You can take like this, your wish. I am taking like this. Next, this is one pair, and this is one pair. See here, please understand. If any term is common in both these K-maps, here it is 0, 0 means A bar, B bar. Here, A bar, B. So if it is anything common in both the K-maps, take A bar common, B bar plus B is 1. You can neglect B. Similarly, in the second and third K-maps, if anything is common, take B as common, neglect A. Here it is A, B bar. If you take anything common here and here, you can take A and neglect the B. Last and first, you can neglect what? You can take B bar common and neglect A. So here, firstly, this particular pair is common in this all the 4 K-maps. So what is the answer for this is, what is this? It is C into E bar into F, neglect AB, because it is common in all the 4 K-maps, neglect A and B, plus for this pair, what is this? A bar, B bar, sorry, for this single term, A bar, B bar into, it is common for this total K-map, A bar, B bar into, now C bar, D, E, F bar, plus here, this is already covered for this pair, A bar, B, because for this K-map, A bar, B is common. Now for this pair, what is this? It is D bar, E, F, plus for this pair, A bar, B, what is this? C bar, D bar, E. Now, this is already covered, this is already covered. So now this is the output expression. Okay, minimized expression. This is how to deal with your 6 variable K-map. In GATE, they may not give you 6, they won't give you generally 6 variable K-map. Up to 5 they can give. If it is in IES, that too in conventional, they can give this 6 variable K-map. Okay, copy it. Let us see the next question, next continuation. Right. The next one, keep the heading. In the K-maps, next part, implicants, prime implicants, essential prime implicants. Keep the side heading this. Prime implicants. Okay. Implicants, prime implicants, essential prime implicants. First I'll give you the definitions, copy it. After that I will explain it. Write down. First heading, implicant. Implicant. Implicant is nothing but a mean term. Implicant. Write down. Implicant is nothing but a min term or max term. Okay. Implicants, prime implicants, essential prime implicants. In that first one is implicant. Implicant is nothing but a min term or max term. So if you are doing SOP, min term is implicant. POS, each max term is a implicant. So implicant is nothing but a min term or max term. Next, keep the heading prime implicant. Prime implicant. Prime implicant. Prime implicant. Prime implicant. It is formed by combining maximum possible adjacent cells. It is formed by combining maximum possible adjacent cells. Please understand here. What is the meaning of prime implicant? It is formed by combining maximum possible adjacent cells. Suppose you are making the groupings. Each grouping is called as simply prime implicant. So you are making quad, octet, pair, single term, whatever may be, all are called as prime implicant. Okay. But here we should take as maximum as possible. Because when you make a octet, don't take internally pairs or quads. As maximum as possible you make a group, that is called as prime implicant. Similarly, when you make a quad where your octet is not possible, we take quads or pairs, whatever may be, all those are comes under prime implicant. Okay. Next, keep the heading. We'll take the example and I will explain you clearly just for continuity. Next heading, essential prime implicants. Essential prime implicants. Essential prime implicants. Essential prime implicants. Write down. Essential prime implicants. It is a prime implicant. It is a prime implicant which contains essential prime implicant. It is a prime implicant which contains. It is a prime implicant which contains at least one min term. At least one min term. In brackets write down max term if it is POS. It is a prime implicant which contains at least one min term, in brackets max term if it is POS. Max term if it is POS. Bracket close. It is a prime implicant which contains at least one min term. At least one min term which cannot be covered by any other prime implicant. which cannot be covered by any other prime implicant, which cannot be covered by any other prime implicant. Now please understand. Earlier I told you in the K-map we have choice. You can take a particular group or not, you have a choice. If you don't have choice, that is what we call essential prime implicant. What is the meaning of essential? Compulsory. So whenever there is no choice, we call it as essential or compulsory prime implicant. Now just definitions you have understand. Now let us take the example. With the example, I will make it clear what is prime implicant and essential prime implicant. Write down. Determine the number of PI. Determine the number of PI and EPI. PI means prime implicant. EPI means essential prime implicant. Determine the number of PI and EPI in the following. So in the next coming questions, let us see. Let us find number of PI and EPI. So take the first one like this. Take this question. Okay, please copy this. Now, first here, this is our question. Forget about that. In this case, how many groupings are possible? Is there any quad possible here? No. Pair is possible as. This is one pair. This is one pair. I can make a pair like this. And also for last and first, you can make a pair. So total how many combinations I have? 4 groupings are possible. So here each grouping is called as one prime implicant. Number of prime implicants is 4. Now in this, how many are essential? How many are essential means, see here. How to identify essential prime implicant from this grouping is, it should contain at least one minterm. At least one minterm which is not touched by any other grouping. It contains at least one minterm which cannot be touched by any other grouping. You see this one, it cannot be touched by any other grouping. You see this one, it cannot be touched by any other grouping. So these two are called essential prime implicants. But if you take this pair, in this pair, this one and this one can be taken by this pair and this one can be taken by this pair. Like that, sir. You see here, these two are called as essential. Now I'll explain the meaning. See here. For example, if you write the solution for this question, this is one answer. What is another answer I'll have? I can have like this. Now, in this, what is the answer? For this pair, it is, for this pair, tell me, B bar C. For this pair, B C bar. And this pair, it is A bar B bar. A bar B bar. Right. Next, here it is B bar into C plus B into C bar plus A bar into what is common here and here, C bar. A bar into C bar. Okay. Now you observe here, you got two solutions. In both the solutions, this is common or not? B bar C, B C bar. Okay. So these are what we call essential prime implicants. Or you can see, you write the solution in any possible way, but these terms will compulsory come. Those are called as essential prime implicants. Is it clear? What are essential means? Compulsory. You have n number of solutions, right? N number of solutions. In every solution, a particular prime implicant is compulsory coming, then it is called as essential prime implicant. Is it clear? So here how many essential? 2. Total prime implicants are, total possibilities are 4. Total groupings are 4. In that 2 are essential. How to identify essential? In that particular group, you have at least one minterm which is not touched by any other. Same, in this particular group, we have at least one minterm which is not touched by any other. Okay, you have at least one minterm which is not touched by any other grouping. In that grouping is called as essential prime implicant. Copy this. Take the next example. Same way. Copy that. Right, see here. First let us make all possibilities one pair, one pair, one pair, another pair, another pair, another pair. So yes or no? So all possibilities, how many I got it is 6 possibilities, 6 prime implicants. In this, which one is essential or compulsory? Let us see. Which particular prime implicant is essential or compulsory? There is no particular min term. You can observe here, there is no particular pair or grouping which is having at least one min term which is not touched by others. So here there is no essential prime implicant. So if there is no essential prime implicant, let us see what is the result. So here you can have two possible solutions. All the 6 can be covered like this, or it can be covered like this. Now see here. Here what is the answer? A bar B bar plus A into C plus B C bar. Here what is F? A bar C bar plus B bar C plus here A into B. You observe here in both are valid solutions. In both the solutions there is not even a single term which is compulsory. We don't have a single term which is compulsory. Here we can say completely different, or there is a technical name we can call here is mutually exclusive solutions. We have two completely different or mutually exclusive solutions in this case. Okay, that is when there is no essential prime implicant. What is the condition? You can have completely totally different solutions here. Copy it.